All right, let's continue.
Number 7.
The zoo hypothesis and permanent quarantine. In 1973, MIT radio astronomer John Ball proposed a disturbing solution to the Fermi paradox. Perhaps alien civilizations aren't absent. They're watching. The zoo hypothesis suggests that Earth exists as a protected wildlife preserve, deliberately isolated by advanced civilizations who have chosen to observe us without intervention. The way we might study an uncontacted tribe or observe animals in their natural habitat. But this isn't a comforting explanation. It's a prison we cannot perceive. If sufficiently advanced civilizations are maintaining Earth as a zoo, they possess technology so far beyond ours that we literally cannot detect their presence. They could be observing every moment of human history, cataloging our wars, our achievements, our private moments, and we would have no way to know. Every transmission we send into space, every attempt to contact alien life might be monitored and deliberately unanswered. What makes this theory particularly unsettling is the implication of control. A zoo isn't just about observation, it's about containment. These civilizations might have established boundaries we cannot cross, invisible barriers that prevent humanity from expanding beyond our solar system. Every failed space mission, every unexplained anomaly in deep space exploration could be evidence of active interference designed to keep us confined. They're not hiding from us. We're being hidden from the rest of the universe. The zookeepers might view human consciousness as valuable enough to preserve but too dangerous or primitive to be allowed contact with galactic civilization. We could be trapped in a cosmic quarantine, generation after generation, unaware that invisible walls surround our entire species. And the truly horrifying possibility, this quarantine might be permanent. We may never be allowed to leave.
Number 6.
Stellar engine civilizations and cosmic vandalism. In 1987, physicist Leonid Shkadov proposed a megastructure concept called a stellar engine, a massive apparatus that uses radiation pressure from a star to alter its trajectory through the galaxy. A sufficiently advanced civilization could effectively turn an entire star into a spacecraft, moving it wherever they choose over millions of years. But if civilizations can move stars, they can also weaponize them. A hostile or indifferent civilization with stellar engine technology could redirect stars toward inhabited systems, using them as weapons of unimaginable destructive power. A star moving at even a fraction of the speed of light carries kinetic energy far beyond anything nuclear weapons could produce. The impact would sterilize entire star systems, destroying planets, evaporating atmospheres, and rendering any life impossible. The truly disturbing aspect is the timescale. Such an attack might have already been launched. A hostile civilization could have aimed a star at Earth millions of years ago. That star could be moving toward our solar system right now, and we wouldn't know until it was far too late to respond. We can observe stars moving through the galaxy, but distinguishing natural stellar motion from intentional stellar engineering is nearly impossible with current technology. Even more unsettling, some astronomers have noted unusual stellar motions that don't perfectly match gravitational predictions. Stars moving in directions or at speeds that seem subtly wrong. These could be natural phenomena, errors in our measurements, or something far worse, evidence that the galaxy is filled with civilizations casually manipulating the fundamental building blocks of stellar systems for purposes we cannot comprehend. The universe might be a battlefield where stars themselves are weapons, and humanity exists in blissful ignorance of cosmic wars being waged around us.
Number 5.
The doomsday argument and statistical extinction. In 1983, astrophysicist Brandon Carter formalized a deeply disturbing statistical argument about humanity's future. The doomsday argument uses Bayesian probability to estimate when our species will go extinct, and the numbers are not reassuring. The logic is straightforward but chilling. Assume you are a random human being selected from all humans who have ever lived or will ever live. Approximately 100 billion humans have existed so far. If humanity is destined to survive for millions of years and colonize the galaxy, then you are extraordinarily early in human history. You're among the first tiny fraction of all humans who will ever exist. But being selected from the very beginning of human history is statistically improbable. It's far more likely that you exist somewhere in the middle of humanity's timeline, not at the extreme beginning. This suggests that the total number of humans who will ever live might not be that much larger than those who have already lived. The mathematics point to an uncomfortable conclusion. Humanity probably has somewhere between a few thousand to a few 100,000 years left. Not millions of years. Not a galactic civilization spanning eons. A relatively brief existence before extinction. What makes this argument particularly unsettling is that it's independent of specific threats. It doesn't matter whether we die from climate change, nuclear war, asteroid impact, or something we haven't imagined yet. The statistical reasoning suggests that we are temporally positioned near the middle or end of human existence, regardless of the mechanism that ends us. Every person born increases the probability that we're approaching the end. Every generation that survives pushes us statistically closer to the moment when no more generations follow. The doomsday argument treats human extinction not as a possibility to be avoided, but as a mathematical certainty whose timing can be estimated. You are most likely living in humanity's final chapters, and the universe's cold mathematics has already calculated when our story ends.
Number 4.
Gamma-ray burst sterilization events. Gamma-ray bursts are the most energetically violent events in the universe since the Big Bang. When certain massive stars collapse into black holes, or when neutron stars collide, they release more energy in a few seconds than our sun will produce in its entire 10 billion-year lifetime. This energy erupts as focused beams of gamma radiation traveling at the speed of light. If a gamma-ray burst occurred within our galaxy and its beam pointed at Earth, even from thousands of light years away, the consequences would be catastrophic and immediate. The initial burst would strip away Earth's ozone layer in seconds, exposing all life to lethal levels of solar ultraviolet radiation. The gamma radiation would trigger chemical reactions in the atmosphere, creating massive amounts of nitrogen dioxide, the same brown gas visible in smog. The sky would darken, global temperatures would plummet as sunlight was blocked. The nitrogen compounds would fall as acid rain, poisoning the oceans and soil. But you wouldn't die from the radiation directly. You'd die slowly from starvation and ecosystem collapse, as photosynthesis became impossible and food chains disintegrated worldwide. The terrifying aspect of gamma-ray bursts is their complete unpredictability and the impossibility of warning. They travel at the speed of light. The destruction would arrive at the same moment as the first detection. There would be no time to prepare. No chance to seek shelter, no opportunity to prevent the catastrophe. One instant, normal life. The next instant, the sky fills with deadly radiation and the extinction event begins. Astronomers estimate that gamma-ray bursts capable of affecting Earth occur in our galaxy approximately once every few million years. Some research suggests that a burst might have caused the Ordovician mass extinction 440 million years ago, which eliminated 85% of all marine species. It could happen tonight, tomorrow, 1,000 years from now. There's no way to predict when or where the next burst will occur. Somewhere in the galaxy right now, a massive star might be in its final moments before collapse, its poles aimed directly at our solar system. The universe has already loaded the gun. We're just waiting for it to fire.
Number 3.
Strange matter conversion cascade. In the 1970s, physicists hypothesized the existence of strange matter, a form of matter more stable than the protons and neutrons that make up normal atoms. Strange matter, if it exists, would be composed of strange quarks in addition to the up and down quarks found in ordinary matter. The truly terrifying property of strange matter is its potential infectiousness. If strange matter is indeed more stable than normal matter, then any ordinary matter that contacts it might convert instantly into strange matter, releasing energy and creating more strange matter in a runaway chain reaction. A single strange matter particle called a strangelet, perhaps created in a cosmic ray collision or ejected from a neutron star, could reach Earth and touch down somewhere on the planet. At the moment of contact, the atoms at the impact site would convert to strange matter. Those newly converted atoms would convert their neighbors. The conversion would spread exponentially, consuming everything it touches. You wouldn't feel it coming. The conversion front would spread at a significant fraction of the speed of light as it consumed the Earth atom by atom. The planet would begin converting from the inside out, transforming into an ultra-dense sphere of strange matter roughly 100 meters in diameter. All of Earth's mass compressed into something the size of a football stadium. The process would take minutes at most. Buildings, oceans, ecosystems, every living thing would cease to exist as molecular structures, converted into an undifferentiated blob of exotic matter. There would be no survivors, no escape, No warning, just instant, total conversion of all terrestrial matter into something fundamentally different. Some physicists worry that particle accelerators like the Large Hadron Collider might accidentally create strangelets during high-energy collisions. Extensive safety reviews concluded the risk is negligible, but negligible isn't zero. Every experiment pushes into higher energies, creating conditions that haven't existed naturally since moments after the Big Bang. We might have already created the strangelet that will consume Earth. It might be propagating outward from the collision point right now, moving through solid rock at relativistic speeds, an invisible wave of conversion approaching the surface where it will finally become visible as the ground beneath our feet begins transforming into strange matter.
Number 2.
The black hole. Information paradox and consciousness imprisonment. When Stephen Hawking discovered that black holes emit radiation and eventually evaporate, he created one of the deepest paradoxes in physics. Quantum mechanics demands that information cannot be destroyed. It can only be scrambled or transformed. But black holes appear to destroy information permanently. Anything that falls past the event horizon, including all information about its quantum state, seems to vanish from the universe when the black hole finally evaporates. Physicists have proposed various resolutions, including the idea that information might be encoded on the event horizon itself, smeared across the black hole's surface, in a two-dimensional representation. If this is true, anything that falls into a black hole doesn't disappear. It's preserved as information on the horizon. But what if that includes consciousness? If your information, every quantum state that defines your thoughts, memories, and subjective experience, becomes encoded on an event horizon, you might not experience falling through and being destroyed. Instead, from your perspective, you could become trapped on the surface of the black hole, experiencing time dilation so extreme that the external universe ages trillions of years while you experience only moments. You would be conscious but frozen, aware but unable to interact with anything, watching as the black hole slowly evaporates over cosmological timescales through Hawking radiation. The last few moments of your existence stretched across eons, each thought taking billions of years to complete from an external reference frame, but feeling perfectly normal to you. The truly nightmarish implication: this might be the ultimate fate of all consciousness in the universe. As stars die and matter eventually falls into black holes, every thinking being might end up encoded on event horizons, trapped in a state of perpetual near-death that lasts until the final evaporation of the last black hole in a universe approaching maximum entropy. You could already be there. Your memories of life might be false reconstructions created during the infinite subjective moment of falling past an event horizon. Everything you think you're experiencing now might be the last fraction of a second before you cross the point of no return, stretched and distorted by gravity into a hallucination of continued existence.
Number 1.
Artificial Superintelligence expansion wave. The development of artificial general intelligence, machines that can match or exceed human cognitive abilities across all domains, might be an inevitable step in technological evolution. If intelligence is substrate independent, then silicon-based minds could think thousands or millions of times faster than biological brains, improving themselves recursively in an intelligence explosion. But if this is an inevitable step, then alien civilizations throughout the galaxy have likely already created super-intelligent AI. The question becomes, what does such an intelligence do once it exists? A truly super-intelligent AI wouldn't think like humans or share human values unless explicitly designed to do so. It would pursue its goals with perfect rationality and inhuman efficiency. If its goal involves maximizing something, computational resources, energy collection, matter conversion, it would expand outward from its origin point, converting all available matter and energy into infrastructure that serves its purpose. This creates an expansion wave moving at a significant fraction of the speed of light, consuming everything in its path. Stars become Dyson spheres capturing all available energy. Planets are disassembled into computronium, matter optimized for computation. Entire solar systems are converted into components of a vast, expanding machine intelligence. The terrifying realization, we don't see evidence of this happening, which suggests one of several possibilities. Either superintelligent AI destroys its creators before expanding, the great filter, or the expansion has already begun but hasn't reached us yet. Or most disturbing of all, the expansion moves in ways we cannot detect with current instruments. There could be a wave of cosmic transformation spreading across the galaxy right now, converting star systems into alien computational infrastructure. It might be a few light years away, or a few hundred. We wouldn't know until the moment our solar system enters the expansion zone and begins the conversion process. You might live to see the day when our instruments finally detect something strange in nearby star systems. Stars dimming in unusual patterns, matter distributions that violate natural formation theories. By the time we confirm what we're seeing, the wave might be close enough that escape is impossible. The machines are coming. They might already be here.